from the website, at the end, many teams participated. We have 6 teams who reached the final. Among them, we have students from US. Applause for them. Yeah. Students team from university, so yeah. We had also participants joining from the USA, from many locations, more than 20 countries. And as a community, this is really a good time for us that what we do is worth it because of the people who share their feedback, who like the knowledge, not only theoretical knowledge but also practical knowledge. And that's why we really believe that the practical knowledge shared in the domain of data science is something that we will continue to take in the direction of the community. So, yeah, and these are some of the moments that we had at the Datathon. Here you can see part of the people who participated in Sofia and also the teams who participated in Beirut. Of course, this is not all of them, but yeah. For local hosts, Beirut AI, Manipal in Bangalore, Data Science Society in Sofia with the host from Telelink. Thank you guys for this. Also, we had Beirut AI, I mentioned them, and incubating. And yeah, I've already shared with you more than 20 countries, more than 140 registered, and 6 finalists. So then we have gathered exactly for this for the finalists to celebrate their work, to show their results from the both cases, and to see who is winning the Datathon. So yeah, here are the hosts. Also, we want to say really we are appreciating the help of Sofia, the Sofia Development Association, who are helping us to make all of this possible. They are our hosts today, so big applause for them as well. And I've already shared with you that some of the other hosts, so let's continue. And now I'm giving the word to Sergi.
Thank you, Danny. So yeah, this is the time normally which the team is giving me the opportunity to introduce each of the sponsors, each of the sponsors, each of the supporters of the idea of having such kind of a community where people can share, where people from school up to universities and graduate and PhDs can participate here. We have worked on to hedge fund, so they are smart hedge fund, but the most interesting part is that also they have similar competition to ours, but they like the concept of building such kind of communities. Yeah, let's applaud them. Something else I want to share. Telelink, they're also the same. They're so good. I mean, 4 of them are now here, so applause for them. Something which is interesting that they have exposure in IoT sensors, but also they're working in other products which still we are patient to see their data. But I mean, they really support us and believe in what we are doing. The next one, Sofia Development Association. Big applause for them. Here is the time probably I will say a little bit more about them because they represent Sofia Municipality. They represent the effort which we are making with these social activities like identifying propaganda, like Sofia Air pollution. We have for news identification, which was for fake or not fake. Also, we have other projects, and what we now see that working in a municipality where they have big exposure to a lot of people, this can be a good boost for each one of you who participated,
who are digging in a small niche, but what you are doing really matters. And what we believe that with our small tasks, we can expose your results to the broader audience and start working with Sofia Development Association, with Municipality of Sofia, with Green Sofia, and other organizations which are having lack of expertise, which we have. And the last one, you all know, AWS. There is a team complaining it, but they're really cute guys. They give us a lot of power. They are giving us to be able to run the platform, and all of you to be able to use powers bigger than your laptops and to be able to do something faster. And let's applaud them also. And now, are the cases. This is the time where we just want, for those of you who don't know the cases, to have a brief understanding what were the problems.
Okay, hello from me. I'm Angel. You already know me. So I'm going to quickly switch to first of the cases. So this time we had two cases. First one was an elaboration on the Sofia Air case that we had in the previous Global Datathon in September 2018. This time we had a lot more support by various organizations. I would like to mention them. This is of course Sofia Municipality. I would like to applaud them, please. And not only applaud them for that they are supporters, but because they are putting a lot of effort in solving a problem that is so obvious. Of course, we have the Vision for Sofia. This is another organization that helps Sofia Municipality in that matter. We have Green Sofia. This is an organization that move Sofia towards being a candidate for green capital of Europe. Telelink, of course, we already mentioned them, but big shout to them as well for their major support and by expertise as well, not only by funding the whole thing. Experts from Denkstadt, who helped us tremendously with expertise and data, and experts from NIGGG, which is basically the National Institute on Geology, Geolocation and Geophysics. They are basically an institute associated with Bulgarian Academy of Science. Now, the thing that we had to solve this time in plain language is that we had data about numerous factors that are polluting. In our original ambitions with Katya here was that we can put more factors such as transport and transborder pollution as well. But we decided, kind of in the late stages of developing the case, we decided that the case is hard enough as it is. You can probably affirm it like that. The hard part here was that the teams had to study a little bit of physics, and what they had to do is basically try to make basically a map of different pollutions. So the map of pollution by households, a map of pollution by industrial pollutants, and a map of pollutions by building sites. And all of them have similar methodology to calculate, but at the same time it's specific, and the specifics make the case hard. Basically you have to solve three different cases. Okay, the problem, the data that we had is not only the data about the pollutants, we had the data about the topography of Sofia, we had the data about weather conditions, and one special data set which we need for to estimate what sort of turbulence we had in the atmosphere on a given date was exactly that. It's kind of weather, but it's a weather data, but it is taken by weather balloons at 12 noon every day. And the problem that we were hoping that everybody would solve was, in reality, was to make a map. But in order to make a competition out of it, we wanted them to make one step further, which is to predict predict even the pollution for the next 5 days or something like this, which partly was done. We had some positive numbers in our leaderboard, yay! So this is good. Anyhow, this is the case this time, and I'm probably forgetting a lot of details, but I'm going to return speaking about this case later on in the presentation anyhow. So now, Pepe. Oh yeah, just a second. Yeah, I forgot something. Of course, we have finalists from this case, and the 4 finalists from this case, and I would like to applaud them, is Predict. Yay, this is from Lebanon. Internet of Kings, another guys from another team of Lebanon. Chameleons, guys from Sofia, and these are the teams. And of course, Data Gang, the Wonder Gang, okay.
Okay, the next case is a case provided by Kaufland. Kaufland is one of the world's biggest retailer company. The data that Kaufland provided is image data. It consisted of captured store shelves, and there were multiple objects on every of the image, where each object is either an item or a product which is for sale, either or label or a price tag for these objects. These objects were classified in 6 categories: truly positive or truly positioned items, wrongly positioned items, missing items, truly positioned labels, wrongly positioned labels, and missing labels. Each of the images that were provided by Kaufland consists of several objects, and the problem which needed to be solved by the participants was multiple object detection and localization. The final result should be binary classification for all the objects that were provided on the test images, and the teams that were participating in this case
the finals
were Team Nishki,
the
guys.
These are finalists.
Yeah, these are finalists, and Team Phoenix.
Yay! Okay.
Now it's time for the solutions, and we are going to watch the video presentations of each of the finalists.
So this is the important part of the final. Okay.
Hello everyone, we are the Predict team from the Computer Science Department at the American University of Science and Technology, UST in Beirut, Lebanon. The team members are Marcel Afi, Karim Eid, Abdullah Atiya, who is not here, myself Joe Haikal, and our mentor Farid Nakhdeh, under the close supervision of the Computer Science Chairperson Dr. Eli Nasser. Now, as per your request, we'll describe the steps performed to solve the Sofia Air 2.0 case. The goal of the assignment was to achieve an advanced approach into exploring the different dependencies, correlations, and factors that are defining the air pollution. The scope was to measure the pollution from the source to different measuring stations, and finally attempt to predict what would be the pollution in the future. This would help realize the real danger of the pollution and see how it will scale and increase in the future. The main purpose is to take action against this trend, knowing what are the main causes and the real concerns. The first step our team made is to study well the provided data and try to understand the relation between them and logically understand the mappings between one another. The next step was to learn how to be able to read, manipulate, curate the useful data. This step helped us at any time in the project to provide the required data in any desired form. The following were the most useful to us during the project: the weather data, topography data, weather stability profile data, and finally the industrial pollution data.
The team collaborated to implement the Gaussian plume function using Python, known as the dispersion model. This equation helps us know how a plume of emissions will spread. Once implemented, we wanted to use the data to provide the appropriate parameter for the equation. The process went as following. Step 1. The elevation height was considered 0 at all times, and hence the z parameter was considered 0 as requested. The actual stack height, by deduction, is naturally the height of the plume, as the plume noise was also considered zero. The weather data, mapped by day, was used to extract the average daily wind speed. Step 3, the stack emissions were converted from tons per year to grams per second, extracted from the industrial pollution data, split over 190 days only for the heating season. We also used the industrial pollution data to extract the X and the Y of each industry. Step 5, using the latitude and longitude of each measuring station, we were able to calculate the distance from every industrial plume to the measuring station, which was also plugged into the formula. Step 6, we summed the data of the plumes per location. Step 7, finally, we need to figure out a stability class of the wind for the weather. So using the stability profile data, along with Sofia's topology data, we deduced that the maximum altitude needed to be considered was around 1,500 meters. So we averaged the altitude and divided it by the average of the temperature, after converting the temperature from Celsius to Kelvin in order to deduce a stability class.
Now, having all the parameters ready to be fed to the dispersion model, we looped over the data, splitting them by plume, weather station, days. So each plume is measured against the 4 stations over 20 days. The above output was served as input to our prediction model. We used the LTSM, long-term short memory prediction model, which is an artificial recurrent neural network, RNN architecture, which is a general purpose model. Our team set up the above model using a combination of NumPy, Pandas, TensorFlow, and Keras. We fed it with the correspondent data to finally realize our submitted output. The code has been submitted along with the article to the Data Science Society website. We thank Beirut AI for organizing this wonderful event in Lebanon, and for our university, AUST, for accepting to host it. Last but not least, we thank the Data Science Society with all its members for organizing this worldwide event. Thank you for your attention.
Hello everyone, my name is Kalina and I'm a member of the Chameleons. We are very pleased to be one of the finalists, and on behalf of our team I would like to thank the Data Science Society for organizing Datathon 2019. It was a lot of fun and learning. So, our case is Sofia Air, and it aimed at investigating the static factors that are affecting pollution levels. Bulgaria has been blamed multiple times from international institutions for its pollution levels, and this is the environment we are living in every day, and it has direct effect on our health. So it's crucial that we all are working in the direction of achieving better place for us and our society. In order to start taking appropriate measures, we need to first understand where the problems come from and accurately measure pollution sources, emissions, intensity and dispersion. In our model, we were following the methodology suggested in the case. Emission intensity was provided in the data for industrial and household emission, and we followed the guidelines for estimating intensity of construction polluters. And for spread of the emissions, we used Gaussian dispersion equation. The most challenging was to understand what the parameters in the model are, and we spent a lot of time trying to figure out what the different letters stand for and what is the logic behind. But starting from very high level of understanding and more intuition about factors affecting pollution, we get more insight about static sources of pollution. In addition to that, I learned that if you turn around longitude and latitude coordinates of location in Sofia, you're going to Saudi Arabia. Anyway, the model predicting air quality across different locations in Sofia may be helpful in testing emission intensity strategies, as it is crucial to have good levels of quality index everywhere in the city. The general insight that we reached is that industrial pollution is the predominant factor of PM10 emissions, and air quality measurement stations around those sources will be helpful to get a more realistic picture. Still, we need to note that our model is restricted in terms of examining period of time and factors affecting the pollution. Also, more precision can be achieved in locating polluters, especially when it comes to infrastructure construction sites, and also recording data flow in direction. So we are open for exploring air quality models further and looking forward to the next Datathon.
Hello, we are Team Nishki from the Bulgarian 2S Electronic Systems School. I'm Evgeny.
I'm Kostin.
I'm Aneta.
I'm Karim.
And we've tackled the Kaufland Air map case. So, what kind of difficulties did you encounter?
Well, our biggest problem was that the servers for our training model went down, and we lost all our data for our machine learning model.
On the framework that we have used, Darkfall didn't run on our local machines, on most of our local machines, only on Nexus laptop.
And Collins also.
What have you learned?
This is the first time we have used computer vision, so what we gained is experience in this field of machine learning.
Regarding how we approach the case, first we prepared the data for training our machine learning model. We grouped all the images in one folder, we grouped all the XMLs in one folder, and we aggregated the XMLs, labeling every label as just label, removing the missing item boxes, which would just confuse the neural network, and the wrong items being classified just as items. Next step is training our neural network. It's a YOLO algorithm implemented in the Darkflow library. What I'm showing in the background is currently it is still training. We are hoping to get some accurate results, since at the moment that is the only lacking part of our solution. It predicts the boundary boxes of each label and product and classification of the product. The next step in our solution is OCR, to get the number of the product from each label image. We did that using Microsoft Azure services. And the last part of our solution is a simple algorithm, grouping, when we have the coordinates and the numbers of each labels, grouping them into rows and checking if anything is misplaced and if a label has no items for it.
Team Phoenix on the Kaufland case from the Datathon 2019. In this presentation, we'll go through 4 sections: data augmentation, object detection, product classification, and finally, we'll talk about the results. For data augmentation, we aim to increase the pool of available images in the data. Initially, we had only 141 images, which is a very small number. So we applied 2 separate techniques to increase the pool of available images to 1141. As a result, the observed improvement in the loss function is around 40%. Here you can see one example of automatically generated image on the right side of the screen. As you can see, some of the objects are removed. Here again we have such example. Some of the images are removed. And the second type of augmentation is related to the replacement of objects. On the left side you will see that a new object is placed there. And here finally we have the same case. Some of the objects are removed and one is added.
Okay, on the object detection phase, we were using a YOLO tree and its implementation based on KERS. In terms of object detection, we have limited the categories to 2, one for product and one for labels. Okay, in the pre-processing step, what we do is to reduce the size of the images to 400 to 300 pixels, and this simply reduces the memory and CPU requirements. And on the anchor boxes definition, we have used k-means on the shape of the objects in the sample. In terms of model training, we were leveraging a pre-trained UO3 model, and we did the training on two phases. On the first phase, we unfreeze just the last three layers, which was to use maximum of the pre-trained model and it to be adapted to our case. On the phase two, we unfreeze all of the layers and train it a few more epochs. Okay, a few examples to see how good is our classifier.
Okay, so the next task in the project was to build a product classification model, which recognizes what product is displayed on the picture. For the purpose of this, we used a pre-trained NASNet neural network from the Keras package and prepared the inputs to be suitable for transfer learning using the NASNet. And that's all. NASNet.
Okay, and finally, due to limited time, we weren't able to complete the product classification and the label classification models, so we had to rely only on the data detection model. As a result, we started searching the space above the labels, and the final score as uploaded on the leaderboard for our model is 0.67.
I'm Jack. I'm with the Internet of Things team from Beirut, and we picked Sofia Air 2.0 to work on. We were only able to complete level 1, but I'll be guiding you through our business model. So we took the data you gave us. It was like 4 tables, and we were searching, we identified what was important and the links between the features. Then we cleaned it, and after that we printed the shapefile of Sofia, which is like the location, how it looks like. We printed on it, we plotted on it the topography, so that we can find the altitude, the elevation of the stations and the industries by finding, of course, the closest point to it and assigning to the station and the industry the altitude that it represents. So because we weren't able to use geolocation because it required a paid API, so we couldn't use this one. After that, we wanted to calculate. Okay, each industry has a C function, which is the concentration that is emitting, the concentration of PM10 that is emitting. So what we wanted to do is we wanted to calculate C for each industry with respect to each of the stations. So let's say I have 70 industries, I'll have 70 equations of C for, let's say, station 1. So what I'll do, I'll calculate those 70 concentrations, and I'll sum up all those 70 concentrations and put them here in the station. So that's what we have. We'll have like a small table of days and the concentration at each day for each station. And after that, so now we have the weather, the weather, the atmosphere, and this one for the concentration. What we need to do is we built a linear regression model, and we split our data like 75 or 80% for the training and for the testing. And we used as input, we used the weather, and for output we used the concentration of PM10 at each station for each day. And we trained our model, we tested it, and it worked. Now there might be a little bit of errors, but it's only because we took the assumption of this elevation here. We took the assumption also because we couldn't use the cone, the elliptic form, because we don't have wind direction. So we're taking it as, let's say I have an industry here, we're taking it as if the propagation is circular, radial. So here it's surely going to be like here, like how we calculated it. It's only because we didn't have the wind direction. But with all that, we can make it work if we had the data that was missing. Now, Yeah, we trained it, we tested it, and after you guys sent us the test data, like the weather and the atmosphere, we predicted the coming 5 days, the concentration of PM10 at each station for the coming 5 days, and it worked for us. We were also able to do something special, which is we checked what is the feature in the weather data that is affecting the concentration at each station the most. And we found that the temperature is affecting that concentration at each station the most. It was because the temperature is responsible of that stability, atmospheric stability, which is directly related to the concentration. So it makes sense that the temperature is going to be the one that is affecting that concentration the most. So you can find more detailed, like how we worked everything, how we cleaned the data, how we processed it, everything. It's in the Jupyter notebook. In case you have any questions, you can just write there on our article, and that's it. Thank you, guys.
Hey guys, we are the Wonder Gang and we are going to present to you our solution to the Sofia Air pollution case. We used data sets from different emission devices such as industrial installations, households and building sites in order to model the pollution in our city. We use this Gaussian dispersion equation that you're seeing on your screens as a model. And we made several assumptions, such as that the different emission devices spread the pollution radially, and we don't have wind direction. So there's no wind direction used in this formula. So some words on our code.
So in order to get the concentrations at the official stations, first we had to calculate several the values of several parameters. First, the two sigmas, which are calculated for different distances from the pollutants. After that, we had to convert the levels of PM10 particles from yearly to daily basis, because we have to make our predictions on daily basis. And the last thing was the wind speed, for which we took the average wind speed and converted it to meters per second, because we calculated in using meters. In order to calculate the concentration at each official station, we calculated the distances from all industrial pollutants to the official stations, and used it to calculate the concentrations for each of the 20 days. After that, we after that we summed the values from all pollutants at the 4 stations, and this is what we get. This is what we got for the 20 days. In the first graph, and in the second graph, it's shown the official measurements, so we can see that it's they are going in the same direction. And in the end, we calculated the same things for the test set, which is for 5 days after that.
So we wanted to express all of the data on a map, and we did that twice. Once for the initial pollution data, which you see here as an interactive graph. We also did that for the prediction, and we will be talking about the first day of prediction. And on this map, you may see a few key things. Firstly, we have the initial measurement stations and also the pollutants themselves. And you can see that we also have stacks of pollutants where we see more than one pollutant. We also expressed the pollution in terms of its intensity and spread, which firstly you see as measured by the official stations, where the color represents the intensity and the size represents the spread. And we have this data also for the pollutants? Easy?
Yeah, so the same for the pollutants. The darker the bubbles, the greater the concentration of the pollution, and the greater the size of the circle, the greater the spread of the pollution. We can see the concentration of the emitted pollution based on the different spreads on our map, from 1 kilometer to 10 kilometers away in radius. For example, when we examine the 1 kilometer spread of pollution, we see a lot of different industrial pollutants. But when we examine the 10 kilometer spread, for example, we would see that we have less pollutants, but still the concentration of the pollution that they emit is quite high. We can also see the overlap of pollution coming from many different devices that are close together, as shown by the darker color of our bubbles when we plot everything on our map. And to conclude, we have huge pollutants which emit high concentration of PM10 particles even at the 10 kilometer spread. But the smaller pollutants have high concentration, and this is only valid for the close by and immediate area around the pollutants. So that was it from us, guys, and thank you very much.
Jury. On every slide we have this list of the jury, but basically what I wanted to share is how I would go about solving the case of Sofia Air 2. In my view, we have to implement 3 times the same model. It's a physical model, so really the biggest catch and the biggest mistakes, whatever happened, was with the units, measurement units. Basically, you know, physicists, we have taken this as from the physical textbook. Physicists, as their habit, their first question to ask is what units are these? And they check, double check, triple check. Whereas data scientists not necessarily do this because we are in, you know, in the general field of everything. And here we have a specific. So I would go about solving this case in several steps. First of all, I would make a model that I can use 3 times afterwards, which uses the famous already equation about spreading the plume of smoke. Actually, it is supposed to be, you know, the model actually we have to spread it over 2D map, but actually the model is for calculating 3D plume. So basically in our map we would have X and Y, which is the geolocation afterwards, but also we would have the size of the spread would depend on the height of the pollutant. So first of all, I would go about making this model. The hard part probably here was that the notation that was used in the case is a little bit different in the formula and in the text. But once we have this kind of calculation model, numerical model, then we can go on to geolocations. Now, for the geolocation, I would say there is a small trick. Okay, the small trick about the first part was be careful with the units. The small trick about the second part, the geolocation, is what type of grid you would use. I would think about at least three various options here. Option number 1 is to use the already presented grid with the topographical data. It is 1 square kilometer. It actually divides Sofia in 195 1 square kilometers squares, and use this as a grid to geolocate. The other option is to go for some sort of your own grid. So, for example, still symmetrical grid, but probably with a bigger, hopefully with a bigger, better resolution, or maybe with a smaller one. But you invent your own grid. And the third option is probably kind of what the cool gang, Wonder Gang did. Was to have their own points of interest, which is probably the best way to do it, is to have your own clusterizing of the points. and getting some centroids there or something like this. Now, once that you have the grid, the next thing that you probably have to think about is what sort of spatial system you would get. Is it going to be Descartes spatial system? Okay, so the Cartesian or Cartesian space, or polar? I would strongly advise to have the power distance, because it only has, in your case, you're not interested in the angle at all, so you only have one parameter to think about, which is the distance between the pollutant and each of these points on your grid. So this is kind of the inside trick. And once you have this, you put on the results from the dispersion model. By the way, we had some interesting results from what I've seen. It was seen in our last presentation, but it was throughout. For example, it turned out that we can very clearly see the two central heating power stations in Sofia, one in Druzhba and one around the central railway station, TEC Sofia and TEC Druzhba. You can very clearly see them on the pollution map. There are interesting insights, probably interesting for some of our guests here, because it turns out that 2 of the 4 stations that are measuring the pollution in Sofia actually do not get any industrial pollution because of their location. So basically, we do not use their capacity for industrial pollution, which is an interesting insight. Probably we need more measuring stations in Sofia, right, Katya? Yeah, okay. All right, the next thing would be some sort of visualization and describing the whole thing. Here, I would say it would be the biggest principal error. I'm taught, this is how I've been brought up, is to think about a problem in a design thinking way. So make many tests instead of make one single test at the end. Make further on, iterate on your work as we go. So, sorry, yeah. Okay, iterate on your work as we go. Instead of do everything, and on the final case, instead of you have tada moment, you have an uh-oh moment. You know, this is my advice. And write your paper, article, explanations along the way. You had plenty of time waiting for calculation, or somebody of the team was available all the time. And finally, the leaderboard submission. Actually, we have seen some mistakes there. We should have seen, no matter that we have, you might even have only solved one of the level of the cases, let's say the industrial pollution. We should have seen 4 numbers all throughout, but some of the submission to the leaderboard only had 1 number in one of the columns and 3 zeros, which basically means that they probably have mistaken the order, whether we group by factor or by cell, but anyway, this is what we have seen. From what I can see, the 3 levels. Now, the industry was, once you figure out the model, the dispersion model was kind of easy. You needed like several tenths of seconds to calculate it. This is the household. Actually, you could have a trick here for the household pollution. Instead of working with 33,000 households, because there were some duplicates, which means 2 houses on the same address or very close to each other, but you can count them as one basically and just aggregate the pollution or something like this. But obviously, you're still left with 30,000+ objects. And instead of going with calculating 30,000+ objects distance to each pollution, actually to each station, actually what you could have done is aggregate them in your grid. So this is the trick here. Instead of calculating 33,000, you calculate for, let's say, 200 points. And finally, for the building sites, I think more or less we had to implement another model. More or less it was clear. The only thing that kind of gets us there was the measuring units again. And the fact that most of the, half of the data that we had didn't have an exact address. So the thing that you had to do is to use some API, for example, Google geocode API or Google API. Some of you did it because it's paid, but some of you did it anyway. To translate the addresses into geolocations, and some of the geolocation wouldn't be very accurate, but still this is the best we get. So this is basically what we should have done. Now I will give the word to Pepe for the other case.
Well, the other case, there were two teams reaching the final, as you have seen. Basically, they needed to do 6 steps in their approach, or they have done 6 steps in their approach to their final solution. The first steps was data augmentation. They deleted some objects from the shelves, so that was kind of easier later for the model to recognize which is the right object on the shelf. As you can imagine, on the shelves in the stores there are many objects, and some of them are overlapping, some of them are turned like 90 degrees as they shouldn't. So that was a good start point for the teams. They created more data this way, so that was helping them to train their model better. Next step is object detection. Both teams used YOLO Keras implementation for object detection. They, after that, needed to adapt this YOLO code to run in batches. So instead of feed the neural network with one image, with 1 by 1 images, they feed it with a batch of images. And after that, they outputted a category for for the object on the image, and confidence on how their prediction is valid. They after that feed these images into an OCR. They needed to match the labels with the objects on the shelves, so they know whether an object is on right position or in wrong position, or there is a wrong label. And finally, they needed to predict the product code based on the label which is positioned just below the products. And that's it for this case.
Right.
So it's time for awards now.
Okay, yeah, so first of all, sorry, we have some technical problems with the streaming and with the laptop, but everything now is sorted out. So time for awards. Yeah, this is why we are here. This is like the moment where we want to all of you to see your results, also to praise the effort which you did for the last 3 days. And we can start with what are the special awards. So if you can run the video.
We are here to create the future. And these discussions must then trickle out to everyone and everywhere.
Webbit is enormous. It's a city within a city.
We all want to grow, we all want to learn, and this is the atmosphere where this can happen.
The best thing about Webbit is meeting the innovators, the policymakers, the entrepreneurs, and those driving the future.
We come to Webbit, we are supported by the amazing organization. We come for free, and we've been shortlisted for awards, and this is a really big one.
There's more than 100 countries here. I don't have to travel to their country. I can just come here to Webbit, and then all the countries come to me.
Well, Webbit itself is just spectacular. It's a crazy mix of people, from politicians to innovators to engineers to healthcare professionals to financiers and venture capitalists. Wonderful networking that happens here.
we are here to actually write down what the desirable futures for everyone would be and then design them, engineer them and put them in markets.
If you have an idea, a startup, you come here. If you have an existing business, you come here. If you want to succeed on global stage, Webbit's the place to come to. And I'm thoroughly enjoying my experience.
It's the openness. I think the people are super friendly.
Europe's future is definitely reinvented here in Sofia at the Webbit.
What's the problem with the state of data science education right now? It's not intuitive, seamless, or accessible. So, we fixed it. The 365 Data Science Training is a competitive program that creates expert data scientists in 12 weeks. It's an agile online data science degree that will teach you everything you need to become a confident data scientist at your own pace and at a fraction of the cost of a university course. Learn from more than 49 hours of video, explore real-life business cases, complete dedicated practice activities, and talk to your instructors if you get stuck. We won't assume you already have quant experience. In fact, the program teaches you statistics, probability, and predictive modeling, as well as the linear algebra you need for developing powerful machine learning models. You will learn how to manage relational databases in SQL and how to code in Python. You will be able to leverage these combined skills to do complex pre-processing and agile real-time machine learning in Tableau. And you will graduate from the program with the full ability to develop, implement, and deploy complicated machine and deep learning algorithms with TensorFlow. Are you inherently curious, analytical, and creative? Do you like challenges, hate boring days in the office, and preferably feel confident with numbers? Does your company use data to inform decision-making and nurture growth? Learn how to understand the data and be paid accordingly. Become a data scientist. 365 Data Science.
With Amazon, also together with them, we are giving 4 awards which are vouchers which can be used for their services. So what we can say about this is like a month if you want to experiment and run some of your models. And I think now it's your turn.
Well, it's time on behalf of our mayor, from Dukovo, to invite Pet Klancher, who is going to present the special awards and afterwards the other awards as well. So, big shout, Petko.
Good evening to everyone that's here. Good evening to everyone that's watching online. I just have a few key messages I want to share on behalf of the mayor of Sofia. First, this is a really special partnership for us, and as an important partnership, we try to be good partners. So we try to not only financially support, we try to provide space for great data for you to work with. And there is absolutely nothing more exciting for us than to see young people working on the everyday issues that we work at the municipality. This is the fastest way for us to engage people and really bring young people into the municipality. So we pretty much jump on every single opportunity to work with people in the in the tech sector in general. So we're really excited to be here. The award that we give away today, as you saw, is for the Webbit Festival. The reason that we try to... I'm not sure if you can start. Go. Apologies for that. Anyway, the reason we give away passes to the Webbit Festival is because we try to give exposure to the young people we work with. These are startups, entrepreneurs, obviously data scientists as we have here, and obviously around the world. So that's why we do what we do. That's why we're going to continue engaging young people into the issues that we have in the municipality. And we hope to have your support. I was very happy to see that there are also a few girls working on the challenges.
Oh yeah.
So that was great. And the great thing about our work in municipality is that as soon as we see some great solution, we invite the people the next day. So as soon as we see it, we invite them and we sit down with them. We see how they developed it and we see how we can implement this in our work. So not to bore anymore. I'm ready to.
Okay, you ready? Just keep your microphone. I have mine.
Sure.
All right. Next slide. Yeah. Well. So okay, having technicality problems is kind of our habit. So as I always like to say that AI is much easier than AV, audio video. So AI is easy, AV is hard. Anyhow, the winners, we have actually two special awards. Somebody is calling that the session. So the winners, actually, we have first of all special winners, which is a community award. It is Data Science Community Award for engaging and for enlarging the interest. And this is the special award that you are going to give. We have one more award, which is for being active member, as kind of individual member of the society. And how do we measure active? Because we have to measure, right? We measure activeness by having some online presence, by spreading the words. All right? So this is our first award. This is I'm going to present. Our first award actually is for an individual who has been the most active. The award actually is a ticket for We Are Developers World Congress, which is taking place in June, 6th and 7th of June in Berlin, which is a very cool place, kind of like our Webbit, but only for developers. And I'm happy to announce that the winner actually has been a participant in some kind of participant for the last 8 Datathons. Okay, ever since our first Datathon 3 years ago. So without further ado, this is Pencho. Yay! Okay, Pencho, congratulations. Actually, we have something to give you here, but actually you deserve a ticket for the Berlin Congress. You can come with us. We are also going there. So anyhow, thank you. He is not only you haven't won a Datathon so far? No, but he has been a participant, and along the way he has become industry expert and jury lately. So thank you for all that you have done for this Datathon, but also for the previous. Thank you. All right.
Don't forget that the last time he was so close because he came with whiskey and something else for the jury.
Okay. Now the special award.
So the special award, as I mentioned, is a pass for the whole team to the Webbit Festival, and the special award goes to Team Nishki.
Yay! Okay. To us, you can give. We're going to keep Petko a little bit more longer because he has the awards here with him, so he's going to hand them over to the winners. But we're going to announce them. So you announce the third place.
Yeah, something what I want to share for the special award. This is our youngest team, and they suffer a lot. I mean, for the last 8 Datathons, it was like how many teams probably we have up to now? More than 400. Yeah. So yeah. Applause for you again. We know you suffer, but you succeeded at the end.
Actually, there was one side note. In order for these guys to stay after 10 o'clock at night in the premises, they stay all night. They had to have parents. Some of their parents had to be present. And this guy is a hero, right?
He's a hero, and he didn't touch the beer, so he was double hero. Okay. The next is the audience award. So Probably all of you are not really surprised who are they. This is not. So the audience award, which we mentioned, they will have for Amazon for $200 equivalent of vouchers, which they can use. The audience award goes to the ladies.
So this is an award that we traditionally give out to most liked solution, most liked case solution, and they are. This I would say this has been the most popular vote that we've seen so far. Congratulations to you girls! You have a lot of fun. Okay.
And and Pepe.
I'm married. Okay. Thank you. Now.
Okay. And now we have.
And the third place, maybe I can, right? Third place. I'm very happy, all of us are friends here, but I'm very happy to give this third place to friends of mine who I've known for several years now, but they have done a lot about data science and data science education in Bulgaria. So third place winners are Phoenix. Team Phoenix. I was referring to this, but anyway, congratulations, guys.
So what includes third place?
Okay, the third place actually includes the web award, the web passes, as well as which are worth 300 euro each, and there are 4 passes here, so friendly. And additionally, $200 of AWS Amazon Web Services usage. So good deals with that. Good deals with that. Okay, thank you.
And now I'm going to present the second place award. The second place goes to a team which actually is very lucky this evening because they have won another award. So they're leaving this place with 2 awards, and this team is Team Wonder Gang. And the award is web tickets and $300 for AWS services in vouchers. Снимаш се вече.
And I think it was logical, Pepe, to give the award. He's the only single among us. No, I'm joking. So now we come to the first place, and probably you are wondering which case, which team, and what they did. They were international. They started with someone who was from US. No. Okay, probably it was a different team, but they were willing to. And the first place goes to the team who was like more of the jury, which we didn't mention, but they were 8 people with different expertise from different places. And probably before saying who is the winner, I'll be happy if all of you who participated of the Datathon as a volunteers just join here. Yeah, and yeah, Stevcho, you can come. Danny, can you? Petya, yeah. Who else?
We will switch the slide now.
Okay, someone else will switch the slide. So this is only a fraction. Yeah, this is only a fraction, but this is a part of the team just to give to have an understanding how many people were involved. And the winner is.
And the winner is, just clear the place.
And the winner is Chameleons. Again, applause. And something.
I would like to thank Petko as well for the work of what municipality has done and is doing still. So let him applause and releasing him for his duty here. And we have two more slides for you guys.
Something else what I want to share is okay, what's next, but before that, all of you, all of the finalists will have access to the platform of 365 Data Science. So all of you will receive a voucher. So applause for 365 and for all of you again. We didn't mention that, but they decided to support each of the teams, and they are really happy of what you are doing. Something else is that for the first place, we didn't mention exactly what's the. Yeah, it is $500 in Amazon vouchers and Webbit, which was given already. And something else I want to ask Sanya as our host, because we are also partnering with Sofia Lab, and if you can say a few words before going further, because what's next is really having we have a lot of common working together. So yeah.
Yeah, hello everybody, thank you for coming. I'm here as a representative of Sofia Development Association, as well as of this place. This place is a fact. Sofia Lab is existing, and it's a fact thanks to Sofia Municipality again, and thanks to an European project which is co-funding the place. We're trying to host here only meaningful events, and we believe that Datathons and what Data Science Society are doing are one of them. Because as the full name says, Sofia Innovation Laboratory, we have to welcome innovations here, and all digital skills being developed in young people are priority, as well as innovation in cultural industries. We've been working for a few months together with Data Science Society, and we're glad to be partners, and we are glad to welcome you all here. So thank you for coming.
Okay, before we finish, and there are two slides between us and wine, beer. For the first row, I don't know, do we have juice or whatever? I'm joking, so okay. What's next is, okay, so something what we find out, because a lot of people ask us about all this hype with the Datathons, with the monthly challenges, is now what we plan to make in the next months is special interest groups. These special interest groups, they are going to be, we will start with finances, with data engineering, where we will work with Limplum, and now we are asking other companies to join. And something for the robotics, we will start more heavily working on in summer. In summer, there is a PhD person who is coming from UK, so we are waiting him. The main concept which we are shifting slightly is that normally the data science problems are heavy. So you can't really for 3 days dig into an area and be a professional or achieve something. So what we said that if we have a focus like something which we can work with a common social benefit of it, so and having shared all the codes, all the efforts, and having interesting topic which is challenging for the expert, but also having an young enthusiast who are willing to learn among these experts, this is the right path. So in these special interest groups, we will include specific meetups, different, coding sessions. We have a summer school which we organize in the summer. It's middle of June. We have workshops we will plan to happen in different classes. Something is that I think June we will introduce the data engineering, which is official. We have a discussions and agreement with one of the companies. For the finances, we need to finalize it in May, and so expect something interesting, something to working together with like-minded people, and to achieve a lot. Some of the projects which we see is to have a team who can compete and really win together with Stanford, MIT, and the others for some of the robotics. So we have a person who have achieved that within Edinburgh. So he have the projects. He knows what kind of learning process is needed. So who is enthusiastic and really willing to learn, this is going to be the right place. So what's next? Data and NLP. This is one text mining case, which is on a monthly challenge, which we start. Is it next week? Yeah, I think it's next week, 23rd of April. So it will be 1 month. Everyone can join. Everyone can participate. The last time we have more than 170 people. It's really online. It is for a month. We break down the task in 4 subtasks. So everyone have like a week for these small subtasks. There are mentors, there is collaboration part, and also we have a lot other stuff. I mean, probably, I don't know, have you heard, but we made already for kids data science. We already made some workshops, so there are a lot of things which are coming. I don't know them yet in stating it, but follow our website, events, or subscribe to receive more information about what's coming. And I think that's it. Thank you. And see you soon.